right, so this lesson is on how to calculate the probability of independent events. So before we get into that, let's do a quick review of multiplying fractions, because this lesson is going to involve multiplying fractions. So if you have 1/2 times 3/4, the way you multiply fractions is you just multiply straight across. So you multiply the top numbers together and the bottom numbers together. And so this would be 1 times 3 is 3, and 2 times 4 is 8. Now you can do that for all of these, but the reason why I have these two other examples is because to make your life easier, you should always check the diagonal numbers to see if they can be simplified. So in this case, the 4 and the 8 have a common factor of 4, so you can factor out that 4. So we would divide this by 4 and get 1, and we would divide the 8 by 4 and get 2. And so now when we multiply straight across, we're going to do 1 times 1 and 2 times 5 to get 1/10. Now, if I hadn't simplified the diagonals here, the 4 and the 8, I would have done 1 times 4 is 4, and 8 times 5 is 40, and 4 over 40 simplifies to 1/10. So it's a matter of either simplifying at the end or simplifying before you multiply them together. And so the same thing here, the 3 and the 9 have a common factor of 3, so I could simplify those to 1 and 3, and I multiply straight across. 2 times 1 is 2, and 3 times 5 is 15. And again, if I hadn't cross-simplified, I'd have had 2 times 3 is 6, the 9 times 5 is 45. You can divide both of those by 3 and end up with 2/15. So it's really a question of whether you would rather simplify 6 over 45 or simplify 3 over 9. All right, so independent probability. What makes something independent? So when the outcome of one event does not impact the outcome of the second event, the events are called independent. So if you're independent, that means that you don't rely on anybody else. You rely on yourself. And so independent events are not affected by other things. So if the outcome of an event does not impact the outcome of the second event, the events are called independent. And when we do examples, this will become more clear. So how do we calculate the probability of independent events? So we're talking about 2 or more things occurring here. So instead of just flipping one coin, you're flipping 2 coins and looking at the probability of, let's say, both of them landing on heads. So independent probability can be determined by multiplying the probability of each event happening. So if you're looking at the probability of A and B occurring, so 2 separate things that are independent of each other, all you do is find the probability of A occurring and the probability of B occurring and multiply those together. So remember, these are going to be fractions, and so that's why we reviewed multiplying fractions, because that's what you're going to be doing. So let's look at some examples of this. So in a board game, students draw a card and then replace it. So they draw a card and then they put it back when they're done with it. And then they draw a second card. So determine the probability of each event. To earn 50 points, a student must draw a heart-eyed card and then an angel card. So independent is because you're putting the first one back. If you didn't put the first card back, then that would affect what is available for the second time you go to draw a card. And that's called dependent events, which we'll get to later. But independent events, you're putting it back in so that the second time you do it, it's not affected by what you did the first time. So the probability of getting a heart-eyed card. So there's 2 of those, and there's 1, 2, 3, 4, 5, 6, 7, 8 cards total. So heart-eyed is 2 8s. I'm just going to write this over here for right now, because I can simplify that to 1/4. Make my life easier since I'm going to have to multiply these. And then the probability of getting an angel card. So there's 1 angel card out of 8. So let's put that in here. And so to find our probability, multiply the top, multiply the bottom, and you get 1/32. Let me erase this 1/8. Okay, so the probability of these two things both happening, you find the probability of each one and multiply them together. All right, to earn 20 points, a student must draw a sleeping card and then an angry card. Okay, so sleeping cards, there are two of those. Same thing as last time, so we have 2/8, which simplifies to 1/4. And then an angry card, there's two of those, so that's 2/8, which simplifies to 1/4. So to find the probability of drawing a sleepy card and then drawing an angry card, we're going to multiply those together. 1 times 1, multiply 4 times 4, and the probability is 1/16. So hopefully you're thinking this is pretty simple. All right, number 3, to earn 15 points, a student must draw an angry card or a laughing card and then an angel. So our first probability is angry or laughing. One of those will work. So how many cards are angry or laughing? So we've got 2 angry cards, and we've got laughing. I guess this is the laughing one with the tears. One of those, so that's going to be 3 out of 8 that are laughing or angry. Okay? And I can't simplify that, so I'm going to go ahead and write it in here. And then the angel, there's only one of those, so that's 1/8. So let's multiply these together, and you get 3/64. All right, and let's look at number 4. To earn 5 points, a student must draw a sleeping card or a hard-eyed card, and then an angry card. Hard-eyed, let's see how many of those there are. So hard-eyed, there's 2. Sleeping, there's 2. So that's 4/8 for that. 4/8, which simplifies to 1/2. And then angry, there are 2 of those, so 2/8 or 1/4. Put 1/4 in here. Multiply straight across. Probability 1/8. All right, so to find the probability of 2 separate things happening, find the probability of each one and then multiply them together. Right, let's look what we have next. So Kylie has a coin and a number cube. She flips the coin once and rolls a number cube once. What is the probability one lands tails up and the cube lands on a 4? So the probability of the tail of the coin landing on tails is 1/2, and the probability of the cube landing on 4 is 1/6. So there's 2 sides of the coin, one of them is tails. 6 sides of the number cube, and one of them is a 4. So we multiply these together, and we get a probability of 1/12. There are 6 marbles in a bag. The 3 are green, 3 are yellow. If you draw a marble, replace it, and then draw another marble, and what is the probability of choosing 2 yellow marbles? And the replacement part, that's what makes these independent, because I'm putting it back in. So what I drew the first time is not going to affect what I draw the second time, because all the marbles are back in the bag. All right, so the probability of drawing a yellow one, there's 3 yellow ones out of 6, and that simplifies to 1/2. So half the marbles are yellow. And so the probability of drawing a yellow one the first time is 1/2, and the probability of drawing a yellow one the second time is also 1/2. So we just multiply those together, and we get a probability of 1/4. One card from a deck of cards is selected. There's 52 cards in a deck, if you don't know, and replaced, and then another card is chosen. what is the probability that the first card is a red card and the second is a diamond? Okay, so a little explanation. A lot of students don't know how a deck of cards works. It used to be that people played cards more and students would know this. So half the cards in a deck are red and half of them are black. So the probability of drawing a red card is 1/2. The probability of drawing a diamond, there are 4 different suits: diamonds, hearts, clubs, and spades. So 1/4 of the cards in the deck are diamonds. So we're going to do 1/2 times 1/4, which equals 1/8. So let's look at this next one. What is the probability of flipping 3 heads in a row on a coin? So the probability of flipping heads, and the second time the probability is still 1/2, and the third time the probability is still 1/2. So then we just multiply all that together, multiply straight across. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And so the probability is 1/8. Neil goes to the pet shop and selects a treat for his dog. He chooses one, returns it to the bunch, and then chooses another. What is the probability that Neil selects a bone and then a collar? Okay, so first of all, there are 1, 2, 3, 4, 5, 6 items here. So he's picking from 6 different items. So the probability that he selects a bone, there's 3 of those. So that's 3/6, which simplifies to 1/2. That's for the bone. And then the collar is 1/6. And so to find the probability of both of those things happening, we multiply those together. 1/2 times 1/6, and we get 1/12. Dexter has 4 different coins in his pocket. He randomly selects a coin from his pocket, replaces it, and selects another coin. What is the probability that both coins are dimes? Okay, so the coins are different. That's important here. So there's only one dime in his pocket. So let's say there's a dime, there's a quarter, there's a penny, and a nickel. All right, so 4 different coins. So the probability that he draws a dime is 1/4, because there's one dime and 4 coins. And so the probability is that. And the second time, the probability is the same, since he's put the coin back in his pocket. So 1/4 times 1/4 is 1/16. All right, last little bit here. The letters of the alphabet, there's 26 letters in the alphabet, are written on cards and placed in a brown paper bag. What is the probability of drawing a vowel, replacing it, and then drawing another vowel? So 26 letters in the alphabet. How many vowels are there? A, E, I, O, U. I don't know. Should we count Y and sometimes Y? We'll count Y. Why not? So we'll say 6/26, which simplifies. You can divide those by 2. They're both even, so you know you can divide by 2 at a minimum. So that would be 3/13. And so first time the probability is 3/13, and the second time the probability is 3/13. So we multiply this together, and we get 9/169. All right, 2 number cubes are rolled sequentially. This means one after the other. What is the probability that the first number cube shows a 2 or a 3? So the probability of getting a 2 or a 3 is 2/6, because there's 1 2 and there's 1 3, which simplifies to 1/3. And the other number cube shows an even number. Well, half the numbers are even, so that's 3/6, or 1/2. So we multiply those together, 1/3 times 1/2, and we get 1/6. And the last one here, Mackenzie chooses one candle, returns it to the bunch, and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? So there's 5 candles. 2 are polka dot, so that's 2/5 times 2/5. Multiply straight across, and you get 4/25. All right, useful and helpful to you. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.